Good morning, good evening, wherever you are, and welcome to episode 34 of the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And today we're going to talk about networking. And Aaron, you and I are sort of old school networking guys. We've never talked about networking on this show. And so we're going to talk a little about networking. And one of the things that Aaron and I do quite a bit is, we try and learn from a lot of people. And a lot of the folks that we learn probably the most from are the guys over at Packet Pushers. And so we did this interesting thing. We thought we'd try out swinging for once on the podcast, and we pinged Ivan, and we said, "Hey, Ivan, would you come and talk to us about networking, but kind of not in the protocol vein, but in the the cloud computing vein?" So Ivan Pepelniak, welcome to the show. Thanks for coming on, man. Glad to have you.
Thanks for inviting me. Glad to be there.
So for anybody who doesn't know Ivan, he does a ton of different things. I'll let you do a quick introduction, but let me give a quick plug. If you listen to our show, you're into the technology of our show, go check out packetpushers.net, which is one of the shows that Ivan drives. So he's a huge contributor to. But Ivan, tell us a little bit about yourself. Give us some of your background, because you do a bunch of really interesting things.
And what I'm trying to do lately is focus more on the interesting technologies, and the really hot topics, as you know, are data center and cloud computing. So no wonder I am focused there. I've been doing a lot of things. So I started in 1985 with DECnet and IPX and AppleTalk, if anyone still remembers those protocols.
Oh, yeah.
Then moved into IP, started the first commercial ISP service in our country, learned a bit about BGP and later things like MPLS, developed a number of courses, wrote a few books. And now, as I said, I am focusing really on technology and research. So I wanted to be chief science officer in my company. They said no. So I am chief technology advisor.
There you go. And Ivan is our sort of first guest from Eastern Europe, so we're trying to expand the reach of the podcast a little bit.
No, it's Central Europe.
Oh, okay.
And we're very sensitive about those things.
So let's just talk about that then. Let's use that as a starting point for sort of the first sort of discussion point. So lots of buzzwords out there today, right? Merchant silicon, open flow. We've got Ethernet networks going to 40 and 100 gig. Fabric networking, software-defined networking, tons and tons of buzzwords, which is kind of interesting if you're into networking, because it's the first time in a number of years that networking's kind of been back in the spotlight and sounding cool again. What's, from your point of view, from the people you're talking to, what's real with all those buzzwords? What's really driving the network space these days?
Well, what's real is merchant silicon. Everyone more or less has figured out that people like Broadcom doing the chips for everyone is cheaper than every vendor doing his own chips. Server guys went through that, I would say, something like 15 years ago. You might remember Sun, Spark architecture, and then there was Digital with its Alpha or whatever it was, Itanium, and so on and so on and so on. And at the end, it was only Intel chipset.
Right.
And we are going through more or less the same thing with networking. So they figured out that Ethernet is good enough. It doesn't make sense to add that many features. We only use 3 protocols, so Ethernet on layer 2 and IP and IPv6 on layer 3. So there are not that many things you can do in hardware anymore that would differentiate you from others. Although some vendors are still sort of not admitting that. But even Cisco, if you look at them, the Nexus 3000 uses merchant silicon like every other vendor. 40 gig, 100 gig, these are exciting things for people who love speeds. Other than that, it's Ethernet as usual.
Right, just the natural evolution of Moore's law.
Yeah.
Yeah. So it's really becoming about software, right? I mean, that's the differentiation.
Yes. And that's why SDN is so exciting to so many people. Because all of a sudden you could start and play and program your network yourself. Not that I would expect many people to do that. I mean, there are Googles and Deutsche Telekoms and Facebooks of the world. And of course, they will program their own network if they have the capability to do so. And there will be the very low-end stuff where, the hobbyist will program something on their 3 switches and will be very happy when the traffic flows in a triangle and not in a straight line. But in the middle, the enterprise networks will probably wait for commercial products. and we are pretty far off from having those.
Right.
And let me ask you this, Ivan. So what kind of, especially on the OpenFlow, what kind of piqued my interest is when both IBM and HP announced OpenFlow switches, because that kind of made the click in my head of, okay, this is really starting to become a product that some of the major hardware vendors out there are starting to embrace to some extent. And are you seeing that as a trend that will continue?
Absolutely. You will see every single vendor having OpenFlow-enabled switches, just because that will become a check item on RFP. The trick is that OpenFlow-enabled switches don't help you much unless you have the controller.
Sure, that makes
HP
sense.
has nothing, and I'm really disappointed because they are more a software company than a hardware company in the networking space. I mean, remember who had the first real network management system?
Right. I mean, you wrote a blog about this just recently about.
Yeah, I was so disappointed because they had this great software, and what they're doing now is they're just giving away the crown jewels.
Yeah, and let me add this, Ivan. So for those that are a little more unfamiliar with OpenFlow and controller and some of the things we're talking about, and to make sure also I'm understanding it correctly. So in the OpenFlow design, the control plane that is typically exists in switches is effectively removed, and everything is moved upstream to what they call the OpenFlow controller, and that is almost the brains where a lot of the switching happens. Is that a correct statement?
That's absolutely correct.
And then, so what you're saying, I'm sorry, just take it one step further. So what you're saying is HP has an OpenFlow switch, but they don't have an OpenFlow controller. So they almost have like the body with no brains.
That's a perfect summary. Thank you. I didn't
just trying to. I'm new to all of this, so I'm trying to put it all into analogies that I can understand. So that was my assessment of it so far. So good.
Yeah, I mean,
and IBM, by the way, had to partner with NEC because NEC has a real production-grade controller, and they did some field trials that I was also blogging about, where a customer was using IBM switches with NEC OpenFlow controller.
Yeah, so it almost feels like if you take the software sort of direction a little bit further, it's the hardware, the things that everybody's sort of used to in switching, in networking today, which was the hardware. The hardware just becomes the roads, the sort of the pipelines between things, or even you could analogize it down to sort of like the lines, what am I looking for? The sort of the copper on a motherboard, right? The things that are moving stuff. And where the intelligence goes or where the control points go either become a software switch, Open vSwitch, whatever version of the software switch, or it becomes that controller, right? Is that where the evolution of where the control points in a network are really moving to?
Apart from mentioning Open vSwitch, you're absolutely correct.
Okay.
So the real difference is that yesterday the control plane was embedded in the switch, and you couldn't move it around. It was still a control plane. It wasn't much different from what an OpenFlow controller does today, but you couldn't take it out. You couldn't replace it with something else, which is what OpenFlow allows you to do. So you take the old body, you put new brains on top of it.
And if I also add a little bit more of, so why would you do that? As far as I could see, and again, correct me if I'm wrong here, but it allows you massively scale. So allows you to scale out much further and a lot more switches in a domain, if you will. And also a big thing, at least from what I was reading, was a lot of the removal of like VLAN limitations and some of these other things that we've had to traditionally do to kind of artificially limit everything just to keep the switches from falling over because it wasn't able to scale. Is that correct?
Well, that is more in the unicorn and rainbow territory.
Good.
See,
good. So tell me why.
Yeah. The problem is that any distributed system is by definition complex. Anyone who has ever tried to program that has figured that out. So NEC, for example, tried really hard to scale things, and they admitted that they got to approximately 50 top-of-rack switches, not more.
Okay.
HP, to give you an example, has a very similar architecture with their IRF, which is Intelligent Redundant Framework or something. So it's the same things as Cisco's VSS, where Cisco puts two CAT 6500s together and they share brain. And HP was promising that 4 switches would share a common brain. They still haven't shipped it, as far as I know.
Sure.
So 4 high-end switches are already a problem from the control plane perspective.
Sure. So it's a bit of theory versus reality at this point.
Yes. And if you read blogs from people like Martin Casado from Nicira, he was initially worried, OpenFlow will take over the world person. And recently he started blogging like, you know what? Maybe it doesn't make sense. After all, IP forwarding works fine. We build the internet with it. Bridging works fine if you keep it small. After all the data centers work. Maybe we should focus on other problems that we haven't solved before. So, for example, what they did, and there is a huge question mark whether that was a good idea or not, but they went down that route. They deployed their own version of Ethernet over IP. So instead of using VLANs, which we all love to hate, they built a totally different solution where Ethernet frames are sent over encapsulated in IP packets. So you just need smarts on the hypervisors, and they use Open vSwitch. And in the middle, you could have stupid IP forwarding fabric like the internet is. And Cisco is doing the same thing with VXLAN, and HP and Microsoft will eventually be doing something similar with MVGRE. And of course, everyone is asking around, well, why do we need 3 competing standards?
Okay, so this is where the thing that Bruce Davey and Nicira sort of sponsored in the IETF the other day called is it STT?
Yes.
Okay. So it's sort of a new variant on VXLAN and NVGRE called STT.
Exactly.
Okay. All right, we'll put a link to it in the show notes. So now we've got traditional networking, sort of embedded switching, forwarding planes and control planes. Then we've got OpenFlow, sort of reversing that, where all the intelligence potentially gets centralized in controllers, and now folks are trying to do this interim where it's, use kind of what you have from a hardware perspective, build tunnel overlays on top of that. Is that fair enough?
Yes,
okay.
That's how, from my perspective, building very, very large cloud infrastructure should be done. Because if we forget VLANs, if we start transporting virtual networks over IP, then they become just another application. I mean, we transport storage over IP already with iSCSI or NFS.
Right.
We transport voice over IP. We transport web data over IP. Why don't we transport virtual networks over IP?
Okay, so help me get that concept then. At least on first blush, virtual networks sounds like a topology concept, whereas like storage is it's kind of just defined bits, or voice is just sort of a certain type of defined bits. Like how do you think about virtual networks just being transported over IP? I'm missing something.
Okay, what we actually need is ability to implement IP subnets, or for the really old timers, the coax cable that everyone can attach to. And we need to implement that in a way that scales, and the only way that scales is IP, not VLANs.
Sure. Okay.
So if you take, for example, a voice over IP network, a phone talks to a controller, says, I need connectivity to another phone, gets the IP address from the other phone, call setup is done, and then the phones communicate directly. At least I hope I got that right.
Right.
And in the virtual networking world, is the same thing. A VM wants to talk to another VM in the same subnet. It sends out a layer 2 frame with MAC addresses, and now the hypervisor switch goes like, okay, I need a session. So it talks to the controller sets things up, informs both hypervisors there is this session coming through, and they start communicating over IP. And the virtual machines are none the wiser. They think they have a direct Ethernet cable between them.
Okay. I'm with you. Yep. Very cool. All right. So let me ask you this. I'm going to kind of change the topic here slightly. Besides cloud and big data and lots of these other kind of buzzwords that are shifting around, one of the other big ones, obviously, when we're talking cloud is automation and orchestration. And what are you seeing on the automation orchestration front these days, and concepts like DevOps? How does DevOps and some of these other methodologies play into networking these days?
Not well.
All right. That's a very fair answer.
The problem is that we are in extremely early stages of what I've been describing 30 seconds ago. So we know we need to get there. We know that will scale, but everyone is still dealing with VLANs and individual networking devices. There are things being done. For example, I'm more familiar with what VMware is doing with vCloud Director, where they actually deploy for every tenant a virtual machine that acts as a load balancer, firewall, that it does NAT and so on. And then they have these virtual subnets hidden behind that virtual machine, which links the virtual networks to the outside world. And you can provision that through point-and-click GUI on whatever web interface vCloud Director has, which is more or less similar to what Amazon does with its Elastic Load Balancer. Cisco has something similar, but they focus more also on provisioning the network devices. So they show you something which should look like Amazon from the web interface, but in the back end, they actually provision a lot of networking devices. And I can tell you that's a major pain, because we did something similar. We have, we call that Flip IT. That's IT as a service, so as far as you can get. And it's VDI with tons of additions, one of them being auto-provisioning. So you, as the customer, add a new user to your company, and in the background, we go and provision everything from the disk for the new VDI machine, the VM itself, the VLANs, the firewall filters, printer, IP phone, everything a user needs. And it takes something like 30 minutes or so. So it's a major pain.
Sure,
right?
sure. And is it safe to say, like, when you talk about automation and orchestration, it's almost like that particular industry or area is a little more mature, and everyone understands what's going on, and so it's now boring and repetitive. So now all I want to do is make this quicker, and
yes.
We aren't to that stage yet, because everyone is still in that stage of we're still trying to figure it out. So I don't know how to automate it or orchestrate it, because I'm still figuring it out.
Well, the problem is, that there is no common blueprint how the networks are built. Well, every data center network is unique. And unique doesn't always mean useful.
Very true. Very true.
Well,
so just figuring out what is in your data center and then tweaking the scripts to configure that correctly is a major pain point. So what we're doing with our service, which because there are a number of service providers who want to offer that, they get a blueprint. This is how a rack should look like, and it has to be wired precisely this way so that the automation scripts will work correctly.
Yeah, I mean, a lot of these things come back to the more sort of consistent you get in the infrastructure, the more consistent you get with how you touch the application. I mean, Aaron, you and I talked about this with Christian Wiley 6 months ago, where it was sort of, DevOps or Chef and Puppet or a lot of those tools. They work great when you're in a web environment where everything is Linux and the tools are, sort of Linux-based, Unix-based. You start throwing in a couple of Windows applications. So, in Ivan's case, he was talking about, defining probably set up a user as a service, which might be VDI, but it might also be an IP phone. Well, you're going to talk to a Citrix or VMware cloud broker in a certain way. You're going to talk to Cisco Call Manager, which is a Windows application, in a different way. You're going to talk to, a network device, which is going to be a different type of thing. It's, you may think it's consistent, but you've got a level of complexity just depending on how many layers you're going to get across. And
exactly.
Yeah. So.
And you talk to every device in a different way, and then sometimes you have to take special precautions because things change between software versions, so it's a major pain.
Right. Right. Well, not to mention, I mean, it's, if you're provisioning application services, if you're basically loading up an application or expanding the number of instances, a lot of that could be hidden behind a load balancer. People may have no idea. They just see a single IP address, and it might be firing up instances or taking them down. You start playing around with network segments that have to then be, they have to be routed, they have to be advertised. We all know from having dealt with routing updates or spanning tree updates or whatever the protocol update is, there's gaps in times there when things won't be visible when you're changing things quite a bit. It's the equivalent of like flapping links, I would expect.
Exactly. And that's what I love, for example, about the Nicira solution. Because, in the traditional world, you would move a VM around. And, for example, VMware, when you do vMotion, it will just hope that the other ESX host is ready and that the server port is correctly configured on the switch. Whereas with Nicira, they only use IP, so if you don't have IP, you can't get to the server anyway. So nothing can go broke there. And because they tightly integrate the Open vSwitch in the hypervisor with their controller, they don't go for eventual consistency, which is what you just described before. Eventually, everything will work. They can actually implement transactional consistency when they move the VMs. So when you move a VM, both hypervisors or all hypervisors in the same subnet are configured at exactly that time when the VM is moved.
All right, I'm with you.
So we sort of talked about kind of the big top level stuff, which you guys did an open flow symposium out in Silicon Valley last year. It was was sort of driven by the really, really big folks. So Google showed up and talked, and Yahoo showed up and talked, and I mean the really, really big guys. We talked a little bit about the kind of the tunnel overlay stuff, which probably could get consumed by decent sized enterprises, folks that have anywhere from 10 to several hundred or several thousand racks, where they're trying to move things, but they're also trying to keep them controlled. What about for smaller folks, or for people that are trying to say, look, I don't have all those skills necessarily. I don't have I may have some guys that do scripting, but I'm more used to sort of I get what comes out of the box. There's some people that are starting to blur the lines just between like compute and networking, right? So Cisco did it 3 or 4 years ago with UCS, but now we're starting to see things like open stack types of offerings, where maybe the network is coming from somebody like Arista, who does sort of traditional stuff with merchant silicon, but they offer some capabilities on top of it, software defined capabilities. You've got people like Piston Cloud Computing, which have this very cool video where it's like a half a rack up in 10 minutes. But do you see, like, what kind of problems do you see? Because you guys talk a lot on your show about the challenges when lines start blurring. What does the network guy still own? Where's his domain of troubleshooting? What are you seeing in terms of challenges when people start blurring these layers between, say, who owns the server side of demarcation points and the network side of demarcation points? What do people have to be thinking about, or what have you guys seen, or what have you talked about that causing challenges?
Okay, so I'll try to remember the whole question. It was long.
Well, I'm mostly interested in the last part of it. When you start, for a while we talk about technology.
I'll start with the first part of it. Yeah. So if you only have few tens or maybe up to 100 servers, stay with VLANs. It would be in a few years. There will be interesting offerings like the combination from IBM and NEC, where you will actually be able to deploy a few tens of switches, connect them to a single controller, and just fire it up, and it will be up and running automatically. And then it will auto-discover itself if it's wired correctly, and then you will just configure the networking part through the GUI. Or my idea in that case would be just let the controller connect to vCenter and pull down the definition from vCenter and configure VLANs and everything else automatically. I mean, it can be done today. It's just that no one did it yet.
Gotcha.
As for the second part of the question, the only advice I could give to, let's say, networking engineers is, stop thinking about silos and stop pointing the fingers.
Right.
Because that doesn't work anymore.
And let me kind of take that a step further. So something that I'm seeing a good bit here recently, talking about blurring lines, is between storage and networking, in the fact you are starting to see more and more NFS and CIFS based network storage appliances that it's more than just I'm sharing files on the network, that you're actually carrying your virtual machine environment or some other very critical applications on, and you're almost seeing a deprecation of Fiber Channel or iSCSI or some of these block protocols over time. And do you see that trend continuing, and do you see those potential lines between a storage admin and a networking admin blurring over time?
Oh, absolutely. Let's say in SMB environment, however you define that, we will probably see all the lines going away, because someone will just have to be semi-fluent in all three areas. He would have to know a bit about servers, a bit about storage, a bit about networking, and be able to provision new VMs or add servers or add disks or add switches on his own. And even with today's state of technology, not products, it's not a big deal. It can be done. It's just that the vendors have to get their act together.
Yes, understand that. So I'll ask you another. Go ahead.
Yeah, as for NFS or iSCSI or CIFS, I was asking that same question for the last 3 years or so, and in 10 days, we'll have a data center fabric symposium in San Jose, which will also be broadcast live. And we will ask the question around. So, do we need Fiber Channel and FCOE, or shall everyone just go with iSCSI? And the way it was explained to me, and I really know nothing about storage, is that the real difference is the management. So Fiber Channel has better management than iSCSI, supposedly. I wouldn't know.
Well, and without turning this into a storage podcast, I will simply say I can see that, and I can see the issues there, and we will certainly put a link to the symposium in the show notes, and it's something I would be very interested in. It's this area in particular is something I've been following a lot very recently, and the developments of FCOE and block storage and what is going to historically happen over time there. So I'm going to ask you a potentially very dumb question. But I'm just going to ask it to get your opinion and see how it fits into the things here. So typically what happens, even if you're doing IP storage, a lot of times, unless you really know what you're doing and you have 10 gig networks or greater, historically a lot of people are carrying all the IP traffic for the network on an entirely separate set of network devices, and then iSCSI, NFS, CIFS, all this other stuff on a storage network, if you will. Again, completely separate switches. We're starting to see with 10 gig and some QoS policies and some of those other things, starting to see a blending of that somewhat. But how would that model fit into, say, the SDN OpenFlow world, and do you need storage at massive scale?
I can't answer the last part, because that really depends on how much data the spinning crust is able to deliver.
Sure.
As for do we need separate networks or one network, as you said, it depends first on the speeds. So if you have 1 gig interfaces, it's pretty easy to saturate 1 gig with today's CPUs. So in that case, it would be a good idea to have separate storage Ethernet network and separate network or data Ethernet network. 10 gig, it's a bit harder to saturate. Plus, it has, as you said, some quality of service built in. So you can a bit tightly control what's going on there. And the really important part is that you control the packet drops. Namely, as we all know, if you lose a single packet in a TCP session, that session will pause for a while, and then it will start transmitting at half the previous speed. That's how TCP works.
Yep.
Now, if you have a few TCP sessions running over a single link, like iSCSI sessions going between servers and storage, probably you will not have that many packet drops. If you have packet drops in that part of the network, you have a problem anyway. If you mix data and storage over the same IP network, then maybe the user sessions can briefly saturate the network, or maybe a database exchange, or I don't know, if you're running a Hadoop cluster, the distribution of load to the cluster nodes generates bursts, and that can cause packet drops. If you keep storage and data separate, who cares about the data packet drops? But if they're on the same network, all of a sudden, a storage TCP session can be hit. And the problem is that you only have a few storage sessions, but they need huge bandwidth, versus thousands and thousands of user TCP sessions. So you can't compare the two.
Yeah,
if you accidentally lose a packet from a storage session, that's a disaster from the performance perspective.
Yeah, and I think you're hitting on exactly why you see such sort of dissonance or separation between the storage crowd from, like, is fiber channel, do we need a fiber channel FCOE, or are those things going away? And them saying, well, it's great for you to say they're all going away, but until you can sort of more definitively do that, because I can do that on a fiber channel network or a better managed network, you're not so much talking about technology as you're really talking about people saying, hey, I have a bunch of scars from being up late at night, or I've seen these problems before. I think what we're getting into is almost like we're going to get into that division that Aaron and I have talked about on a bunch of shows, which is like it's not so much the storage protocols, it becomes the applications, right? If you've got super latency sensitive databases, that are doing whatever online transaction processing, you're going to have a hard time telling the fiber channel guys they got to do something different. But if you're having somebody building a large scale, application that really ends up becoming like an iPhone app, they may not care about drop packets at that sort of level. So, but trying to tell those two guys that their worlds are the same is a little bit tricky. You're not gonna. They're gonna sort of say, "Hey, that's not what I do, and that's not what I care
exactly.
about."
Yeah, and it's one of those, again, theory versus reality. In theory, you should be able to do it as long as everything's designed properly. In reality, it's still a lot of Ghostbusters. You can't cross the streams. If you do, disaster results, right?
Well, if you deploy PFC and ETS, so these are the priority-specific pause frames and weighted round-robin between priorities over Ethernet, then at least you can make iSCSI and NFS lossless. So yes, if you have a major disaster and your network melts down, then of course you'll also lose the storage part of it, but at least you won't get packet drops.
Well, so you got that going for you. It's a bad day, but you didn't drop any packets.
Exactly. As for can SDN help, in theory, it can. Because in theory, you could program microflows in the switches all the way through so that a particular elephant session would be recognized and handled differently. Now, in practice, that's a bit different. Because first, you don't want to have that many flows in the core switches because they probably couldn't handle that. And the other problem is that the applications and the operating systems can't really tell the network what they need.
Right.
You guys probably remember RSVP, right?
Oh, God, yes. Yeah.
So we had a mechanism where a session could indicate that it needs special QoS treatment for 2 decades. Is anyone using it?
Nope.
What does that tell you about the application developers?
Well, and it sort of, to a certain extent, it sort of highlights the fact that throw more bandwidth has always sort of been the de facto quality of service, as opposed to all the fancy queuing and other things that have been out there. So, yeah. A
QoS is always an afterthought. It works nice in the lab, then we put it in a real network, and oh my, it doesn't work as well as it did before. Well, right. It must be the network problem. That's the only thing we changed.
Add more pipes, make them bigger.
Yes.
So you talked a little bit. We're sort of getting towards the end here. You talked a little bit about some symposiums you've got coming out. You guys are obviously looking at you're looking at fabric in what's going on in sort of fabric networking. You were recently doing stuff around OpenFlow, and you continue to do that. What else is occupying your brain? What other kind of interesting challenges are you starting to look at, and what are the spaces people can expect to see you doing webinars for and talking about going forward?
Well, one of the other things will definitely be IPv6, because there's a lot of confusions about IPv6 and how do I deploy, for example, content on IPv6. So there will be a few webinars on that topic. The other topic that I'm also focusing on every now and then are VPNs, and I'm trying to persuade Juniper to help me with MPLS VPN on Junos, so that I wouldn't be that Cisco focused in some of my webinars. But still, the data center and cloud computing is like 80% of what I'm focusing on today.
Okay. Very, very good. Well, listen, Ivan, thank you so much for coming on. It's it's good to get back to talking about networking. We spend a lot of time trying to talk about apps, and it's also good to sort of realize that there's a level of reality to some of this stuff, but a lot of it's still, will the vendors implement it? Will the standards evolve? Which is, pretty similar to what Aaron and I deal with on the cloud side. There's about 20% reality, and there's about 80% theory. And the cool thing is, the stuff's moving pretty fast. People are figuring certain things out, and they're letting certain things, go to the wind. And I'm glad you came on. It was fun for us. I think we probably could ask you questions for a long, long time, but thank you so much for coming on.
Thanks for inviting me.
All right, so we are out of time for this week, but before we close out the show today, I just wanted to say a quick thank you to all of the positive reviews we've had on iTunes recently. We've had a nice little spike in iTunes reviews. So if you find the show valuable, please take a moment and rate us out on iTunes. Again, Aaron's rule, 5-star only rule, please. And then also I want to say a big thank you to the folks over at Rackspace. It's not an official plug or anything like that, but we've had a number of rackers email us with great feedback and about the show lately, and we just wanted to say thank you to them. And they actually have a Cloudcast listening party going on, which is just mind-blowing to me, the fact that our podcast is getting that kind of response. So thank you very much to them. Very, very cool. So in closing, you can follow us on Twitter at TheCloudcastNet, or reach us on the web at thecloudcast.net, where you'll find links to our show, our YouTube channel, and links to the show and show notes, and links to iTunes and Stitcher. Thanks for listening.